Okay, let's start our course now. Hi everyone, welcome back to CeADAR Lighthouse Project AI Digital Twin course. I'm Yilin, the data science in the CeADAR AI Digital Twin project. Yeah, and today is our second session for the AIDT course. I would like to introduce the specific use case of AI Digital Twin in healthcare and help you to understand the usage and the implementation of the AIDT through real use cases. And we will discuss and design our own AIDT at the end of the session. Yeah, and let's start by reviewing the core concept of AIDT. AIDT, as is like the simplest, is a digital replica of a physical entity. It could be a machine, a human organ, or process, an entire city, or as we focus on today, is aspect of the healthcare. And AI and machine learning are the brains behind the AIDT. They analyze the data, recognize patterns, and even predict future outcomes. In healthcare, it means like predicting patient health trends, potential applications, and more. And what actually is AI digital twin in healthcare? It is a virtual representation of healthcare process, patient health, and even the entire healthcare system powered by AI and real-time data. This technology is changing the way we deliver and manage healthcare service. Imagine that future where healthcare is personalized and predictive, a world where doctor can visualize your health metrics in real time and simulate various treatment options. And like you are in hospital and your doctor use the display showing a digital twin of your body, they can see and simulate everything from the cellular interaction to organ function. It's allowed to real-time monitoring and quick decision-making, ensure the most effective treatment for you. And all it sounds amazing, but in fact, they are not far from us. So today I will introduce how AIDT can help us in real life medical development. Now, I want to start by sharing a few outstanding examples of AIDT in the medical field. First up is the diabetes model proposed by the Andy and Schlesinger back in 2003. They use different equals to build an AIDT model that replicates diabetes at the high level of biological and clinical detail. This model can be applied to a wide range of clinical and management problems that can even be validated. These currently include biotypes and its applications enable to address the comorbidities and the treatments with the multiple outcomes. Imagine being able to simulate the testing and treatment of diabetes in different patients. This is the kind of innovation that AIDT make possible. Yeah. And another fantastic example is the artificial pancreas that's created by the 𝖣邸and the teams in 2019. The model simulates the action of the human metabolic system and use readily arrived real-time signal like continuous glucose monitoring to automate the insulin delivery. And with the control algorithm that optimize blood glucose condition in the patient's nature environments. The transition of the artificial pancreas to everyday clinical use is occurring, and the seamless working with the device that patients use the digital therapy ecosystem. And the last but not least, let's talk about the cardiac digital twin created by the 𝖫키RiЛ𝗓𝖺 and Shan and their respective teams in the 2019. They built a digital twin model of the heart that detects the predicts cause of the thrombus and simulates the flow of the blood through the heart. Just imagine having a digital twin that allows doctor to visualize your heart condition and make accurate prediction about your health. So by briefly introduce some real-world example of the AIDT in healthcare, like we maybe have some general understanding of the use of AIDT in health. So next, I will introduce healthcare use case and the AIDT key components in healthcare in more detail in these three directions. Like the first is AIDT for heart disease prediction and management. The second is AIDT for IoT healthcare system, and last is AIDT for optimizing hospital operations. Yeah, the first AIDT for heart disease prediction and management. We will develop it to an exciting application of AI in healthcare, the health digital twin for cardiovascular disease. This innovative concept, like as detailed in a comprehensive reviews from the Nature Digital Medicine, marks a significant advance in the heart disease. Firstly, we need to understand the burden of heart disease and the current challenge in managing the heart disease in order to be better able to proceed with the objective setting. Yeah. So the cardiac disease accounts for approximately 1/3 of all deaths globally, and the leading cause of the disabling adjusted life years. Ischemic heart disease in particular is a major cause of the premature death. That is very horrible things. Yeah. And the current method for estimates the risk of the cardiovascular and the ischemic heart disease relies on the algorithm incorporate a small number of traditional risk factors. However, the sustainable number of events occurring in individual is considered the low risk by this algorithm. So this challenge indicates that the accurate and personalized risk assessments with the tolerate prediction treatment remains critical. And the needs for all optimized and the effective use of the preventable medical device and therapies. So what kind of health AIDT does this research propose? This is a vital presentation of the patient that receives real-time updates on the range of data available to predict disease and optimize treatment option. This digital twin concept organized from the industry practice of creating the virtual models for the physical system and now being applied in healthcare, like particularly in the cardiovascular disease management. And also, the precision medical is an evolving field worldwide, seeking to more accurately phenotype individual patients with the same condition, allows tolerate screening, diagnostics, and treatment. The healthcare digital twin reflects the concept by integrating the patient-specific treatment based on the virtual replicas to predict the outcome and personalized progress. The health digital twin for heart disease demonstrates that's how AI and digital twin innovation can lead to more effective and personalized and predictive healthcare. This is a prime example of the potential to improve patient outcome and relevant the healthcare practical. So let's jump to AIDT's key components in healthcare. We'll talk about the three aspects: the data, the algorithm, and the simulation. In the AIDT ecosystem, data collection is fundamental. The health digital twin received various data parameters that are crucial for the patient's decision-making and predictive assessment. And the heart of the health digital twin is in this research creates a population-based database that is divided into two basic data types. And the first type is deep phenotyping, which is from the integrated electrical health records that concludes the biological, clinical, genetic, and the image data. That is the first type. And the second type consists of real-world data captured from the person's environment via the mobile data sensor and wearable devices. This data reflects how individuals interact and live in the real world. And assimilating continuous acquire the data from the multiple resources into the clinical knowledge is an important step. It involves data like pre-processing, data mining, and data integration, all of which produce richer information that any single data source can provide. In the cardiology, this integrated phenotype data is analyzed with a predictive framework that uses a combination of the statistical and mechanical modeling. This approach facilitates the advanced reasons in the digital twin and paving the ways for personalized cardiologic the treatment. Yeah, and each person's health digital twin is selected from the database to present the average characters of the closed population. This selection is critical as to form the baselines for the personalized care. And the result of the virtual interventions on patients are feedback into the database. The dynamic circle not only refine the individual twin, but also enrich the population data pool, improving the accuracy and representations of the model. The accuracy and the depth of data collection and management makes the health digital twin a transformative tools in healthcare. And also in the field of digital twin for treating health disease, the integration of advanced AI and machine learning plays a key role. These algorithms are crucial in analyzing and interpreting the vast amount of health data collection, leading to more accurate prediction and personalized treatment plan. The health digital twin for heart disease, like this research, utilizes various AI and machine learning algorithms, including the deep learning and convolutional neural network. This technology allowed for the complex pattern recognition and analyze for the large database. And like this research we're discussing, they utilize the logistic regression and decision tree to analyze the data from electrical health records, wearable device data, and environment factor, and use deep learning and convolutional neural network to fundamentally change the disease outcome prediction. And this approach enabled the prediction of the disease progression and the effectiveness of the different treatment strategies. So the next step is the simulation, modeling, and the real-time monitoring are implemented in the health use digital twin for the heart disease. The health AIDT use complex simulation and modeling technology to replicate and predict the progression of the heart disease. This includes the use of the statistical and mechanism modeling based on the collected data. For example, the model can simulate the impact of different medication on the patient heart health, predicting the potential outcome and help to develop a personalized treatment plan. And an important aspect of the health AIDT is the ability to adapt to new data, providing real-time insights for ongoing patient care. This allows to continuous monitoring and adjustment of the treatment plan based on the latest health data. Let's imagine a wearable device on a patient that's continuously monitor the health rate and the blood pressure. The healthcare digital twin could use the real-time data to adjust the treatment, like recommendations to ensure the best possible care for the patient. Yeah, so the health digital twin for the heart disease is groundbreaking approach that's leverage the AI and machine learning algorithm for predictive modeling. That's comprehensive data collection. And okay, let's dive into the concept in this AIDT model of the heart disease. And like showing the picture, the process begins with the data collection. Yeah, the cornerstone of any AIDT. In this case, they collect the biometric data, which may come from the wearable device that track heart rate or blood pressure, that patient reported clinical condition and lab test results. These various data sources provide multi-dimensional views of the patient's health. And once the data has collected, this enters the verifications and the storage phase. Here, the data is integrated, verified for the accurate and stored security. This step ensures that the data used for the digital twin of the highest quality and integrity. And the third Once the data is prepared, we move to the core part of the model, the simulation. Yeah. Using the established digital technology, they predict output from given input to efficient create a twin. The digital twin behaves and reacts like the real world counterpart is the patient heart. Yeah, and the essential feature of our digital twin is the dynamic nature. The model is accessible to the cloud, receiving the real-time updates and change to the input data. This means that the twin model changes as the patient condition changes, which that simulation results remains accurate over time. Next is the machine learning algorithm to apply risk data and parameters dividation to make the diagrams. This algorithm analyzes trends and patterns to accurately predict the potential health outcome. Finally, we have the output, the actionable information generated from the AIDT mode enable the physicians to make informed decisions, and this provides a predictive perspective that can guide the treatment plans, adjust the medications, and even suggest lifestyle changing for the patient. So this digital twin model is a powerful tool in the figure that's against the cardiovascular disease. This allowed us to predict, managing, and personalize the patient care in a way that previously is impossible. So here is, let's go to another AIDT in the healthcare use case, the intelligent context-aware healthcare system design. That is Yilin and the team in the 2021 designed to the system that aim to improve patients' healthcare and refine the healthcare process through the innovative application of the technology. And you can see, you can have a look in the figure. That is the foundation of, of the architecture is the IoT wearable sensor. These devices are crucial to obtaining the real-time data about the body metrics directly from the patients. And they from the first point of contact in the AIDT system. The data collection from the IoT device is the cornerstone of building the digital twin. As shown in this figure, this data passes through our system and undergoes a transformation process that creates the virtual replica of the patient. When enter the digital diagram, raw data undergoes strict cleaning like this. This is then like the pre-processing and transform to make it suitable for detailed data analysis in the next stage. And the heart of AIDT structure is the AI system that's do the data analysis and the machine learning. And this intelligent system uses processed data to build the various predictive models to continuous monitor health and detect the anomalies earlier. And the important aspect of the AIDT structure is to facilitate the collaboration between the healthcare professions And the DT provide a platform for these professionals to prescribe treatment, conduct tests, and monitor patients' response in a virtual environment. So in order to apply the above framework to real life scenario, they also present a use case for system implementation for the patient DT that monitor real-time health status and detect optimize in the body metrics. The core of our system is the real-time capture of the ECG signal use the wearable sensors or the smartwatch. Once captures, this signal are digital pulse that inform the machine learning algorithm. Then once digest, the ECN signal can be pre-processed and filters. The crucial stage refine the data and ensure that it is in optimal condition to effectively train the machine learning model. So using the prepared data, they built 5 different machine learning models to diagnose the heart condition. This model can discuss between normal and abnormal reasons, a key indicators for the health care. And this model employs a variety of algorithms, including the CNN, MLP, and the logic regression, long short-term memory network, and so on. This diversity allows us to test the performance of the entire dataset and identify the most accurate health prediction model. And by digital the ECN signal at the high sampling rate, we can accurately capture the heart behavior. The dataset classify heartbeat into the 5 categories and ranging from the normal beat to the unclassified beat allowed our model to learn from the wide range of the cardiac event. And the evaluation focus on the occurrence, sensitivity, and the specificity, and the ability to generate the on-sea data. The model, especially those utilizing deep learning, like the CNN and the LSTM, show high occurrence, demonstrating the feasibility of using digital twin for real-time cardiac monitoring and anomaly detection. So as shown in the figure, the micro average is average the technology that calculates the total TP, FP, and when the test dataset is unbalanced, that is to calculate the precision. Yeah. And the deep learning algorithm, such as the neural network that can outperform the traditional algorithm, which the LSTM models scores is highest in this accuracy. That provides the potential of the deep learning in the medical diagrams where pattern recognition plays a vital role. Yeah. So let's jump to our next use case. The area where the stakes are high and dynamic that ever change. So this is our hospital. As the heart of the healthcare sector, hospitals are facing the continuous challenging, and are no less complex than the other sector of the healthcare industry. However, resource planning for a complex system such as hospital is complicated and difficult due to the variability associated with the changing resource ability and the increasing demand. So that the hospital plays a key role in the delivery of the critical service in the evolving healthcare sector. They face numerous challenges, including the agent's need to balance the growing demand for service with the effective resource management. And our healthcare system is experiencing unpredictable growth, partly due to the aging population and the rising incidence for the chronic disease. This growth requires not only more service, but also higher quality care while controlling the cost. At the heart of the problem is a mismatch between the demands and the capacity. Hospitals need a solution that provides a near-instant snapshot of the available resource, enable them to adapt quickly and efficient to change the need. And imagine how great it would be we can manage the staff scaling and the patient flow and the ward allocation in the real time and be responsive to change in demand as they occur. As real-time analog-based digital twin are the key to improve the efficiency of the healthcare delivery. So as a result, 𝖠kiRiL𝗓𝖺 and the team developed this paper to present a groundbreaking approach, a digital twin model that not only replicates the hospital service, but also simulates various strategic planning scenarios to optimize resource utilization and patient care. As shown in this figure, physical object, the real object in the real space provide data to digital object in the virtual space, which analyze the data, learn from it, and can then feed information back to the physical object to improve the performance. And in this paper, they defined a digital twin in relation to hospital service as the creation of a virtual replica hospital computational model that simulates the different healthcare aspects and the service of the typical hospital function. The model is a near perfect replica of the real-world hospital service using the current real-world data. And the use of digital twin as a real-time decision support tool for patient flow management is an innovation in healthcare, especially in hospital. For example, if a patient has an unforeseen situation during the medical visit, it is possible to predict different options for the patient in the near future, thus assessing the consequence of the different events and the outcome. And they also use the FlexSim healthcare software to create 3D visualization of hospital twins to assess and visualize patients and staff loads to make data-driven decisions for the resource management. And this software is 3D simulation and monitoring tool. It provides a rich set of solutions for the hospital, clinical, and nursing facility and the care process. This can be used to design the model with variety of input and control parameters to help optimize healthcare process. That healthcare decision making can use this to optimize resource utilization, planning, and design all aspects of healthcare organization, and visualize and assess the potential risk of the scenario under the study. And as shown this figure, this paper proposed a new approach capable of the simulating hospital service. It's focused on the simulating patients' pathway or the process with a hospital by creating a digital twin based on the secret event simulation model. This enables different scenarios to be applied using the simulation model to test modifications to hospital service and the patient's care, thus identify the opportunities to improve the efficiency of the patient care. And in order to make the simulation real-time and accurate, they proposed the approach employs technology to collect care data from the hospital information system on the regular basis, as well as the technology to connect the contextual data using the IoT and the computing service to demonstrate the process methodology. The FlexSim software was used to create the 3D visualization of the hospital twin model to assess and visualize patient and the staff flow factor and the parameters during the simulation model run cycle. And as shown in this picture, is designing the simulation model. They designed a flow chart that describes the different steps or care process that patient goes through when using different hospital service, as shown this. And this is to build the patient's pathway flow chart. And this diagram shows the 3D simulation models of a hospital patient pathway. You can see here. And different scenario can be tested in this software before the actual application. And within the development of the smart device, like communication technology and the IoT devices, is become the leading technology for collecting real-time data in the wide range of application in many fields. And for example, in the healthcare, IoT device can be used to track the flows of the patient from admission to discharge in real time. This helps to reduce the waiting times, lower the cost, and improve the quality and the safety of the care. Additionally, IoT device can be used to track medical device and multiple medical equipment. This helps get the patients and the necessary equipment to the right exam room or operating threat at the right time. So in order for the digital twin to be more effective, they need to collect real-time data in much detailed as possible to create the real-time digital simulation mode that can update and change as the physical model change to predict the performance and service requirement. So they use the DES, the discrete event simulation. Is the one of the many tools and methods used to analyze and improve healthcare delivery. That's paper focus on how DES can be used to assess the efficiency for the hospital delivery system. And in fact, the DES can also be considered as the tool for the developing model to observe the dynamic behavior and the performance for the real-time process. Yeah, that's DES application are focused on the various aspects of healthcare, such as the accident and emergency rooms or the outpatients clinicals. That is focused on the healthcare simulation. So you can see here, after implementation, the hospital digital twin model using the discrete event simulation and the IoT data, they can observe some transformative results. The model provides a dynamic and interactive visualization of the hospital option and allows us to gain the valuable insight. You can see as shown this figure, we can understand how long patients wait in the treatment pathway. As mentioned earlier, these are number of factors that affect waiting times in the simulation. Like for example, the nurse, the doctor, the other resources such as exam rooms or beds. So the most important impact is in resource management. Through simulation, hospital administrators can expert with the different resource allocation strategies to be use beds, schedule the staff, and manage the patient flow more efficiently. Okay, so to conclude today's session, let's take a look back at the course we have taken in the field of the AI digital twin healthcare. We have explored 3 underbreaking use cases. Each demonstrates the transformative power of AIDT. Yeah. So these 3 use cases each highlights the impact of the AIDT in healthcare, and we stand on the new areas in the healthcare delivery. One in which technology not only supports but enhance human decision making to improve the patient outcome. Yeah, I can see in the chat. Yeah, they are already implemented in the healthcare. It's all the real world use case, and this all implemented in and do the research in the healthcare field. Yeah, and here now is our quiz time. And because I want to, in an interesting way, to see how much knowledge you gain from today and the last session. Yeah, you can have a look. I prepared 6. I prepared 6 quiz, and you guys can scan the QR code and answer the question. Yeah. The first question is, what is an AI digital twin primarily used for in the industry setting? Like, is the physical product manufacturing, is the creating a virtual representation for the simulation and analyze, is directly interact with the customer, is replacing human workers. Okay.
Thanks, Yilin, for beautiful use cases. You helped us to understand and go into the details. And hello, everybody. That's a very interesting question Yilin has raised. Let's see, what do you think? So perhaps I think everybody has replied the question. Yilin, if you can show us the result to see.
Yes. Oh, yeah. Everybody have answered the correct answer. Yeah.
Okay, so creating a virtual representation. So that's a good news. People are not thinking to use technology to replace human workers or direct interaction with customers or physical product manufacturing. Yeah, that's kind of a virtual. Very good. Let's see the second question then.
Yes, and let's see the second question is, like, what kind of data does AIDT typically integrate for simulation? One is only history data, only future prediction, real-time and history data, and the public available data only. Yeah, you can answer it.
Very good question. It helps us understand the difference between simulation, shadow, and digital twin, as we have emphasized on that previously. So, okay, good participation in the question. 12 out of 14 have replied real-time and historical.
Yeah. That's, yeah.
Actually, in terms of the data, future prediction is not data, but historical data. Publicly available data only, that's incorrect, but publicly available data can be used for training purpose. I mean, at the end of the day, in the back end of your AI digital twin solution, you need to develop and machine learning algorithm, train models, etc. Over there, perhaps you would need to have access to publicly available data for that. But for the digital twin itself, you need to have the historical data and also the real data. Interesting. Go to next question then.
Yes. Next is, how do AIDT interact with IoT devices? Yeah, IoT control the IoT device remotely and are usually unrelated, or it can simulation and analyze, or IoT can replace the need of AIDT. That.
Okay, interesting. Let's see.
Oh, yeah. The first is have few people select the first AIDT controls IoT device remotely.
Controls IoT devices. If IoT devices are considered as sensors, then they just collect the data. And then so AIDT solution, they don't control them. Control them, it might be. I wouldn't say it is incorrect, because in your digital twin solution, you have IoT devices, you collect the data, you bring the data into your digital twin. At the back end, you apply model to that data and you generate insight, blah, blah, etc. Okay, here in objective, you have already decided about your solution. One of the output would be you send back some signal to your IoT devices. You can change their mode of data collection. I would say yes, it is possible to collect to control IoT devices remotely also, but it uses data from IoT devices for simulation analysis. But the people who have replied, I hope it is multiple choice questions, Yilin, isn't it? People can
Yes,
select
yes, yeah,
multiple options. So the people who have selected the first option also is very interesting and kind of smart option, I would say, to control IoT devices. Yes, it is possible. Very beautiful. Okay, let's see what else you have for us today.
and the first is what is one of the key benefits of using AIDT in healthcare. Like you reducing the need for patient visit and no need for medical research and allow for real-time monitoring and predictive analysis and completely automating the patient care.
The questions gets actually more challenging, more and more challenging.
Yes, yes.
Okay, so most of us, we think allowing for real-time monitoring and predictive analysis, which is accurate, I would say. Reducing the need for patient visits, that could be, yes. It can help us in terms of how it can reduce the need for patient visit. For example, if you have enough data from patient and if your AI machine learning algorithm, your solution, let's call AI digital twin solution, can detect some of this kind of symptoms, etc., from the data, can advise the patient with that data. Even doctors, we can have human in the loop. I mean, people, professionals in the healthcare also, they can, apply some feedbacks, etc. Yes, definitely, it can reduce the need for patient visiting. I would say completely automating patient care, the last option. Is it possible to do that? In some cases, it might be possible for some sort of the really, of course, I'm not the healthcare professional. I'm not sure if there are diseases or situations that you can automate the process completely. But perhaps no need for medical research is wrong because AIDT cannot do the research for us. But that's a good point to say. You can develop, it's not like developing AI digital twin in healthcare to, optimize hospital operation or to help drug discovery or to help monitoring patients, diseases progress and so on. It could be a tool for researchers, for medical research. I mean, you can bring all those data into a digital twin and then they can test everything in advance. And in the use case that Yilin was presenting, the scenarios, different scenarios in optimizing the hospital operation, that's crazy. If you don't have digital twin, if you want to test those scenarios yourself, how much time, how much cost you should afford to be able to test, and how much, patients, employees, everybody involved in all these things, they would suffer to see if that specific process, that a specific scenario for optimization works or not. But AI digital twin can, nobody is affected. In a digital world, you have a copy of your whole hospital, you have a scenario, actually you test the scenario, you see which one works the best, and then you immediately apply it to the real world. That's really insane. Very beautiful. Let's jump to the next question then. Please jump in if you have points, guys. If you have any points or question or something to add, please open your microphone and contribute.
Yes. And for this question, how does AIDT utilize data in healthcare, if including the privacy, using data to create the history report and integrate the analyzing and the virus data and storing data without analyzing it? Let's see the result. Yeah.
Okay,
That's a kind of simple question. Yeah.
by using data to create a yeah, that's very important aspect to consider, integrating and analyzing various data for enhanced decision making. That's very important question. Do you have any more question, Yilin?
Yeah, the last one, the most difficult, I think.
The most challenging one. Okay, let's see what's that.
Yeah. What does DES stand for in the content of optimizing hospital operations with AIDT?
Yeah, that's
Yeah.
a very specific question.
Yeah, that is I mentioned in the course.
You wanted to test us to see if we have followed what you have said, Yilin?
Yeah, yeah, I want to see if you are followed my course, my voice.
Okay, let's see how many people have followed what you have said.
Oh,
Okay, very good.
seems
Okay.
like most people followed my course. Yeah, this is the discrete event simulation. Yeah, it's can be considered as the tool and the methods for developing the models to observe the dynamic behavior and the performance of the real life process. It's mostly used in the healthcare monitoring,
Yeah,
healthcare simulation. Yeah.
very beautiful and very good. Okay, so one thing that I want to come back to it and say was the platform Yilin in one of the slides mentioned, the FlexSim. If you can bring that slide again, Yilin.
Yes.
So that's a good example to show you in the world of AI digital twin, when you want to develop a digital twin for your case and problem and so on. It is a good idea to see what kind of the tools you have access to. So if you go back to a few slides before this, yeah, this one. That's a very interesting platform. As you could see in the hospital, optimizing hospital operations, they could actually, the guy actually Yilin cited here, you can see in their paper in 2018, they have used this tool to simulate the environmental thing. So imagine in the case of, in all of the cases, imagine if that's the smart city case, if it is healthcare, if it is, let's say, industrial stuffs, etc. Tools like this are important. So I just wanted to come back to this to emphasize again. Okay, so if you want to use AI machine learning to, you know, collect a lot of data and then model the data, develop some sort of the deep learning model to predict something, to classify something, and so on, that's one thing. But then when you want to develop an AI digital twin, which receives the live data, actually feed the data to the AI and machine learning model and so on, that's very important to see what kind of you know, tools you can find from different scenarios. I mean, sometimes you don't believe it, that's a real tool, we can use it and you can receive a lot of benefit from. So for example, in one of the demos that we were working on, it was what was that tool that actually we were using? That was the agent model, agent-based models. You could really simulate the whole environment in 3D. You could create like actions and so on. That was really interesting one.
Yes.
Yeah.
Yes.
So that's very important to take care of that. Another thing that I wanted to focus on, emphasize on that was, if you can keep the slides, the last slide you have, I would say, Yilin. Yeah, the other thing I wanted to say, the focus of this slide was a little bit, okay, along the week, we are trying to cover different use cases of the digital twin and explain different challenges you are facing with when you are designing the digital twin. But in general, what I'm saying is we want to focus on a specific stuff at each session. At this session, we wanted to focus on objective setting. That's very, very important. When you want, okay, so in the healthcare, did you see we could develop different kind of AI digital twins? But based on the objective of AI digital twin, the scenario completely is changed. So when you want to design an AI digital twin, even specifically in a specific use case, you need to, at the very first stage, you need to understand and define what is your objective. So let's bring an example. Imagine we want to develop digital twin to optimize the performance of remote working hubs in Ireland. Okay, then it could be completely different if you want to see what is the pattern of people method for commuting from their home to remote working space, if they use their own car, if they are using public transportation, cycling, walking, and so on. So we can target that thing and develop the AI digital twin. We can jump from there to somewhere else. We can focus on their engagement inside the building, inside the remote working hubs. We can focus on energy efficiency of remote working hubs. See, the objective is very, very important. The objective determines what kind of the data you need to collect. The objective determines what kind of front end you would need. Do you need to have any 3D simulation? Do you need to have any kind of application do you need to develop to collect the data, etc.? What kind of the AI and machine learning algorithm you would need to use in the backend? Again, that's because of your objective. And if I want to give you a quick recipe of how to define the objective, I will bring 3 steps. The first step is, the first thing is you need to come up with the pain point that you want to solve. What is the pain point? What is the main problem people are facing there? I mean, if that's optimization of the hospital operation, you may come up and say, okay, we have resources, we have people engaging with the resources. We want to come up with more optimized scenarios, but testing the scenarios takes a lot of energy, time, effort, cost, blah, blah, etc. It's the pain point, how to solve it. So first thing, you need to come up with the pain point, okay? The second stage is to see what kind of the data do you have access to solve this pain point. I mean, okay, I come up with the pain point, with the problem, but there is not that much data to solve that problem. It is not possible. Okay, we are living in an era, actually, we are living in an era that plenty of data are available, but still, in a lot of cases, we don't have access to data. And sometimes we have access, data are available, but because of the privacy stuff, etc., we cannot easily have access as to develop models, AI models, and so on, to develop our digital twin. So the second question is then, what kind of the data do you need to address to solve that pain point? Do you have access to that data or not? Accessibility of data and the way you collect your data and so on, it will affect you changing the pain point, the problem you want to solve. It has happened to us in the demonstrator that we have developed in the AI Digital Twin Lighthouse project, okay? So that's the second step. And then the third step is what kind of the approach, what kind of the AI machine learning technology you want to use to solve, to provide people with a solution to that pain point, okay? Sometimes you have data, sometimes you have data, but the data you have are unlabeled. We have data, we don't have problem with the privacy, but data are unlabeled. So supervised machine learning algorithm won't work for you. You need to go for unsupervised, you need to go for semi-supervised or self-supervised approaches. Sometimes the problem you are going to solve, you are facing with a kind of privacy problem. Okay, so you need to bring in privacy preserving machine learning algorithm to solve that problem, okay? So all these 3 things, 3 steps together, which is called our recipe inside Lighthouse, AIDT Lighthouse project, let's call it, will help us to formulate the objective. But that's the very first and the most important step you need to do. Of course, you need to have a big understanding of the whole problem, but you need to come up with your objective, and then based on that, you can start developing the architecture of your AI digital twin, and then you can start doing the rest of the stuff. These are the things that Yilin and we will continue meeting again and again in the next sessions, in different use cases and different scenarios, and also in the homeworks that you are going to do with the use case that you will select, you will have the opportunity to take care of all these steps and other things. Okay, Yilin, I think you have something else for us, isn't it?
Yeah, and about the grouping, homework grouping. Yes, we received like 13 people's response.
Yeah, to the form, and it looks like 13 people are interested in doing the homework, which is very good. And based on what they have replied, and to speed up the process, some people, they were interested to do that individually. They already knew what is their use case. Some other people, they were free to join the group, but they knew what kind of industry they are interested in, and so on. So accordingly, Yilin and I decided to group people in this way. So I think, Yilin, we will send everybody an email tomorrow, perhaps, to let them know their group and the project and so on. And also we will share with the groups, individual or group of people together, we will share you some sort of a spreadsheet with the list of all questions. Imagine if in designing an AI digital twin, we are facing with 6, 7, 8 different stages, like objective setting, data preparation, like deciding about your AI and machine learning algorithm, like the backend, like the front end, the ethical aspect of your problem, and so on. Imagine if there are the sections and different parts we need to discuss, and each part, actually, we will ask you a lot of questions, I mean 5, 6, 7, something like that. And then while you are doing the homework, we wanted to keep the focus of everybody in a specific question, instead of making that open-ended question that it takes a lot of confusions and so on. So we'll provide you with the spreadsheet, individual groups and group of people together on their project. And then along the course, you can start working on the your homework, working on the question we have asked. And whenever you need any help and so on, you can, if that's a spreadsheet, you can make a comment, mention Yilin, and Yilin and I, we will answer the question, and we will work together. And hopefully in the last session of the course, some of you who are interested in presenting what you have developed, we can have some of the presentation in the class to discuss them.
Yes.
So I hope that's something you like to do.
Yes.
Okay, any question, any discussion, anything you want to raise? Very good. It looks like we don't have question. Anyway, you are already in the community. Please, Yilin will post all the link to the papers, everything into the community. And please, if you have any question, etc., reply to the post on the community. Also, you can reply the emails that Yilin sends, and you can discuss your challenge, question, etc., in the email too, if you are happier to follow up with the email.
Yes.
Good. If there is no more question, Yilin, I think we can close this session 2 of the course.
Oh, yes. And here you in the chat. Hi, can you let us know when a decision will be made on group?
Oren, thank you very much for asking that question. In the spreadsheet that Yilin actually shared, we have decided about the group. In your case, I think that has been an individual one, but Yilin will send an email tomorrow, and in the email she will let everybody, each group knows what is the spreadsheet they need to work on, what are the questions, and so on.
Yes.
That would be the solution.
Yeah.
Okay, I will leave it to you, Yilin, to close the session.
Yes. Thank you, Aliza. And thank you, guys. Bye. See you next session.